We are going to continue the velocity time graph. We stopped at that point last time, so we are going to continue from there in velocity versus time. Velocity time graphs. The graph is very important in physics. Of course, it will describe the motion. For example, if we have a velocity time graph and we have a graph like this, a small graph, here is the velocity in meter per second, and here is time, and here we have a velocity against time, velocity against time, time in seconds. If the graph line is represented by a straight line passing through origin, it means this object is moving with constant acceleration, So we need to define acceleration. Acceleration, by the way, is the vector physical quantity. Acceleration is a vector physical quantity. So in order to be fully defined, we need to know magnitude and direction. All acceleration is vector physical quantity, but in some books we are going to see the magnitude without the direction. So we are talking about the magnitude of the acceleration, not on the acceleration. So acceleration is the vector physical quantity. It depends on the change in velocity over the time of the change. And what is the unit of velocity? Is meter per second. What is the unit of time? Is second. So the unit of acceleration is meter per second or meter per second squared. If we are going to simplify this, we are going to put v minus u divided by t. What is v? V is the final velocity. Final velocity. What is u? Initial velocity. What is t? T is time. So final velocity minus initial velocity divided by time will give us the average acceleration. If the line is passing through the origin, let's return back to our graph. If the line is passing through the origin, it means the object is moving with constant acceleration. What is meant by constant acceleration? If I'm going to say that this an object is moving with 5 meters per second squared, what's meant by this? If we are going to describe it like, we are going to say that the speed of the object increases by 5 meters per second every second. So it means the speed increasing by 5 meters per second every second. So here is what's meant by the acceleration is 5 meters per second square. If the graph is represented by a straight line parallel to the time axis, so this object is moving with constant velocity, constant or uniform velocity. If the object is moving with constant velocity, so there is no change in velocity. If there is no change in velocity, it means there is no acceleration, no speeding up. So acceleration is zero. So acceleration is zero at this point. Acceleration, as we said, may be positive or negative. Acceleration may be positive or negative. If we have a positive acceleration, it indicates that the object is speeding up. Speeding up. And it means the final velocity is greater than the initial velocity. So these, if the acceleration is positive. If we have a negative acceleration, sometimes they call it retardation or deceleration. So at this case, the initial velocity is greater than the final velocity. It's like we are using the brakes. So if the driver is using the accelerator, so we have positive acceleration. If the driver is using the brakes, we have negative acceleration. So what if we have, let's return back to the graph. We have a velocity time graph, and if the graph is curved line like this, so we have again increasing, but at this time increasing in the acceleration. So we have increasing in acceleration. So the acceleration is not constant. The acceleration is increasing uniformly. What if we have a graph and the graph is a velocity time graph also, but the graph line is like this, small line like this. So we have a decrease in the acceleration. Decreasing acceleration. It's not deceleration. We have a decrease in the acceleration or the magnitude of the acceleration. And of course we can use the same graph like in the previous lecture. Here we have a velocity time graph. We are going to compare between the acceleration of two objects. Here is the first line, and here is the second line. If we are going to have two objects A and B and we are going to compare between them, so the acceleration of A is greater than acceleration of B because the graph is more steeper. Okay guys, let's apply on this. Assume we have a displacement time graph and we want to change it to a velocity time graph. I'm going to erase this and I'm going to draw it better. And I'm going to try to draw the graph smooth. It seems like it's difficult to draw inside it. No, it's not difficult. Here we have a graph starting from the origin. We have a displacement time, and here is a point, and this point, like we have a moment of change. We have the origin, we have the acceleration, we have a point A and we have point B. We have a displacement time graph, and I want you to draw this graph in velocity time graph. In what? Velocity time graph. During my drawing, please try to do it. We have a velocity time graph, and I want you to draw it. If you looked here, we have an increase in the speed, increase in the velocity, by the way. Here is displacement, so we have increase in the velocity. So and the increase is uniform, so we have an increase in the velocity, and I'm going to draw it by a line, a straight line. And then we have a decrease in the velocity, so I'm going to draw it like this. And we moved horizontally at this point, so the velocity is 0. So here is the origin, here is point B, and here is here is point A, and here is point B. If we are going to draw the same graph in acceleration time graph, we have now acceleration time graph. What do you think that graph will be? I'll give you like 3 seconds to think about it. We have a uniform acceleration, and this acceleration is constant, so I'm going to draw a horizontal line like this. I don't know why it's not a straight line. And then we have a change directly, so I'm going to draw another line, and we have a negative acceleration or retardation, so we will have this line in negative side or in negative direction. Should be horizontal, and I'm going to add the line here. So we have positive acceleration and we have negative acceleration at this point. So here is the representation, here is the origin or the midpoint, and here is the point A, and here is point B. Okay guys, we are going to stop here, and we are going to start inshallah uniformly accelerated motion in the next lecture, inshallah, lecture part 3 related to kinematics. We are going to stop here.